So how do we come to learn about cells? Well, to help answer this question, we're joined by Dr. Duncan Driver. Welcome, Dr. Driver.
Well, my doctorate is in poetry. It's a PhD. I don't know anything about biology.
But you are a doctor, right?
Yes, of literature, screen and theatre. Ow!
Just read the script.
Oh, okay. You don't need to get nasty. The study of cells began in 1660, when English physicist Robert Hooke melted strands of spun glass to create lenses. He focused on bee stingers, fish scales, fly legs, feathers, and any type of insect he could hold still. When he looked at cork, which is bark from a type of oak tree, it appeared to be divided into little boxes left by cells that were once alive. Hooke called these units cells. Although he did not realize the significance of his observation, he was the first person to see the outlines of cells, and he initiated a new field of science called cell biology.
That's fascinating. Imagine designing your own microscope and being the first person to see cells. Please, tell me more.
Well, in 1673, Antoine van Leeuwenhoek...
Leeuwenhoek.
Anton von Leeuwenhoek of Holland improved lenses further. He used only a single lens but produced a clearer and more highly magnified image than most two-lens microscopes then available. One of his first objects of study was tartar, scraped from his own teeth. To his great surprise, Leeuwenhoek saw what he described as very small animalcules that were moving around under the microscope. What he was looking at were bacteria and protists that people had known existed. In the 19th century, more powerful microscopes for improved magnification and illumination revealed details of structure inside cells. In the early 1830s, Scottish surgeon Robert Brown noted roughly circular objects in cells from orchid plants. He saw the structure in every cell and identified it in cells of a variety of organisms. He named it the nucleus, a term we still use today. Soon another scientist distinguished the translucent moving material that made up the rest of the cell, calling it the cytoplasm.
And you can still see these structures in biology class today very easily using compound microscopes. Go on.
In 1839, German biologist Matthias J. Schleiden...
No, that's pronounced correctly.
Oh, good. Thank you. Matthias J. Schleiden and Theodor Schwann proposed a new theory based on many observations made with microscopes. Schleiden first noted that cells were the basic units of plants. And when Schwann compared animal cells to plant cells, they concluded that cells were elementary particles of organisms, the unit of structure and function. Schleiden and Schwann used their observations to formulate the cell theory, which originally had two main components. One, all organisms are made of one or more cells, and that two, the cell is the fundamental unit of all life.
So that was the start of the cell theory?
Yes. Well, according to the script I'm just reading now.
Fascinating.
German physiologist Rudolf Virchow added a third component to the cell theory in 1855 when he proposed that all cells came from pre-existing cells. This idea contradicted spontaneous generation. When the French chemist and microbiologist Louis Pasteur finally disproves spontaneous generation in 1859, he provided additional evidence in support of cell theory.
Thank you, Dr. Driver. I understand since the discovery of DNA structure and function in the 1950s, the cell theory has focused on the role of genetic information in dictating what happens inside cells.
How am I supposed to know?
Turn the page over.
Well, yes. The modern cell theory and the ideas that cells have the same basic chemical composition use energy and contain DNA that is duplicated and passed on as each cell divides.
So in reality, this theory has not been finalised yet and could be further developed by our biology students.
Well, I suppose so.
Well, thank you, Dr. Driver, for providing your insight into the development of the modern cell theory.
Well, you're welcome, I guess.
So I was wondering if you would take a look at this rash that's been bothering me.
I'm not a bloody biologist or a medical doctor. I studied Shakespeare, for God's sake.
Well, that's the end of today's broadcast on the development of the cell theory. Join me next time when Dr. Driver will explain how microscopes have been used to understand the size and structure of cells.
I'm not coming back.
Goodbye.